So this second video is going to visually connect the multivariate model to that univariate model. So in the multivariate model, we had the orange line, which is in the multivariate 3D plot. And that's within the orange line within the multivariate 3D plot that's lying within the best fit regression plane. So a 1 unit change in high school degrees or less is associated with a 0.36% increase in shifting to Trump in the left graph. That's what we just saw in the prior video. But it's also associated with that same change in the right graph. But that right graph is a three-dimensional plot. So the line in the regression plane also has to change values with respect to income. A 1% increase in high school degrees or less is associated with both a 3.36% change in shifting towards Trump and an, as yet, unknown change in income. The two-dimensional plot ignores the input of income, but it doesn't mean that the effect of income disappears. It just means that the two-dimensional plot is hidden, whereas in the three-dimensional plot you can see it. So the univariate regression, we had median income is also associated, in addition to having high school degrees be associated with Trump vote, high school degrees is also associated with median income. Specifically, median income is equal to negative $1,195.19 times percent of the district that has a high school degree or less, plus $108,773. That is, a 1% increase in high school degrees or less is associated with a $1,195 decrease in median income for that county. A county with high rates of residents not attending college, 70%, expects to earn around $35,000 in median income per year. And so that's looking over at this section of the graph. It's fairly low down. And you see that around 70% high school degrees or less is associated with $35,000 or so of median income. On the other hand, a county with high rates of college attendance, 20% or so without college, expects to earn around $75,000 in median household income per year. Now you can see this exact same relationship in the right-hand graph. So when we're looking at that left-hand graph, we can take the orange regression line in the 3D plane, which is the univariate model predicting Trump support in 3D, and we can spin this 3D plane to view the relationship between income and education. Specifically, I want to swivel this around until I can see that same pattern, namely get high school degrees on the x-axis and median income on the y-axis, and spin that around until this graphic matches or comes pretty close to that left-hand graphic in the PowerPoint. And in the PowerPoint, I've actually screenshotted that, and you can see that this matches pretty well perfect. It is very clear this orange regression line is, in the left-hand plot, it's identical to the orange regression line in the right-hand plot. It's just that the right-hand plot is in 3 dimensions. In order for a 1% increase in high school degrees to create a 0.36% change in the regression plane, the county expected median income must go down by the associated $1,195.19 that we saw in this graph. So this is the association here between median income and high school degrees, and you can see that the univariate model that we saw is actually defining a joint change in income and education. Both of the following regressions must hold. You must have the regression that defines the relationship between the Trump vote and high school degrees, and the relationship between median income and high school degrees. Now, it's very typical in standard analyses to focus on that first regression line and interpret it as if income doesn't matter. I want you guys to be aware that income does matter, and it's defined according to the second equation. Note that this change is driven by the effect of education. The influence of income is secondary, since income is not actually included in the univariate regression.